Now in this code, I have function called shortest path Bellman which will take the reference to graph and source vertex ID as argument. Now inside this function, our first goal is to initialize the vertices as we need. For that, I have called initialize and find vertex function with source ID. Now inside this initialize and find vertex function, I have initialized all the vertices distance to integer type max and predecessor to null. For source vertex, I have set the distance to 0. Now after that, in our Bellman function, I am going to iterate through all the edges number of vertex minus 1 times. For that, I have first set the outer loop count and then I am going to iterate through all the edges that amount of time. Now notice that before call relax function for particular edge, I have first test the start vertex distance is not integer type max or not infinity. Now there's two reasons for this condition check. First thing, we know that if our start vertex distance is infinity, then the relax function will not be able to do anything. Second reason is that inside relax function, we are adding some weight to start vertex distance. Now if our start vertex distance is maximum value, adding another value to that particular variable will result in undefined behavior. Therefore, before calling relax function, I have checked whether our start vertex distance is integer type max or not. Now inside this relax function, I have checked whether the end vertex distance is greater than the start vertex distance plus weight. If so, I am going to update appropriately. Now after iterating through all the edges number of vertex minus 1 time, and finally I am going to iterate one more time through our edge list to verify whether the negative weight cycles is in this graph or not. If so, I am going to return false. In the Bellman main function, I have recreated the graph that we discussed in our presentation, and then I have called our Bellman function on that graph with source vertex as S. Now let me run this example and verify whether the outcome is same as what we get in manual run. So if I run this, you will see that the distance value and the predecessor ID values we get here is same as the values that we got in our manual run. So this is how we implement Bellman algorithm, and that's it for this video. Thank you.